So in the lecture we have looked a lot at how firms behave, how they optimize their profits, but the kind of firm we've been discussing was a very simplistic firm, which was a good place to start. But of course in reality firms are way more complex, they make a lot more different types of decisions than the ones we have been looking at so far. In particular, also, firms are more complex in the sense that they often consist of several other firms or several other factories. And one sort of way of how we can start to make our model a bit more complex and realistic is that we can sort of see how we can extend our framework to decide about how a firm would sort of decide how to allocate production over several production facilities it might be having. Yeah. How would it decide how much to produce in which factory? And so in case the firm has 3 factories like here or more. And as usual, what matters in that decision, what is an important factor is the cost, and specifically the marginal cost. And again, the simplest way you could start this is if you just think about 2 factories, 2 plants that are owned by the same firm. And what might be the case is that you're in a situation like the one which is described here, that you have different marginal cost curves. So you have one which starts a bit lower and goes then much higher for plant 1, and you have another one which starts relatively high but doesn't increase as fast for plant 2. And again, just to be clear about this is in a space where we have the quantity of either firm plant 1 or plant 2 on the horizontal axis, and here we have values such as costs or the marginal cost. Okay, now what do you think how we should allocate production between these different plants? One sort of particular neat way of expressing that is a slightly different diagram, which looks like that. And what this diagram kind of tries to answer is the question, say we want to produce an output, a total output, QT of the amount QT, and imagine that the QT can be represented by this length from here to here. Now what we can do, instead of drawing the costs for the 2 firms from the left to the right, as we just did in the previous diagram, we can draw the costs for one of the plants. Say here for plant 2 we start here on the left and go to the right, and that is our marginal cost for the plant 2. On the other hand, for plant 1 we start on the right hand side. That's the, if plant 1 produces 0 units, and this is if it produces QT units, sorry. Whereas here for plant 2 we have the marginal cost when it produces QT units. Now, how does this diagram help us to decide where this firm as a whole should be producing their output? Well, let's start from the beginning. Let's say they just want to produce a small amount, say 1 unit of output. Where would they start producing? Would they start producing in plant 1 or in plant 2? Well, if they start producing in plant 2, it will have a cost here of this length, which is sort of equivalent to the intercept of plant 2 with the y-axis. On the other hand, if they would start in plant 1, then of course the cost would be lower, it would be virtually 0. Yeah? So it seems like a good idea to start in plant 1. And then if they expand production, would they carry on in plant 1? Yes, they would, because the cost here is lower than even producing very little in plant 2. But there comes the point where the cost of producing 1 more unit in plant 1 is just exactly the same height, and that's indicated here by this sort of dotted line. It's the same height as the intercept of the marginal cost of plant 2. So what this means basically is that once we have reached this point, it starts to make sense to produce also in plant 2. Yeah? So at first, if we only have to produce that amount, we would start in plant 1, but then if you want to produce more, we would also produce in plant 2. And then if you go beyond this point here, then we would always sort of produce in both plants, and we would want to make sure that in either plant the marginal cost is the same. And in particular, we would end up in this point here where they both intersect. What is now the interesting point, or the interesting thing about this point? Well, the marginal cost is equalized in both plants, and they produce exactly this total amount of QT. So what this tells us, if we want to produce an amount QT, the way we have to distribute it is in order to make sure that the marginal cost of production across all plants is just equalized. Yeah. And of course, we also have to check that the amount we are producing is not lower than this amount Q0 here, because if this would be the case, then we would only be producing in production plant 1. But in this particular example, that's not the case. We would produce at a point here where the two marginal cost curves are just equalized, but also the sum of the two production amounts, here the production amount of plant 1 and the production amount of plant 2, just sum up to Qt. Yeah, and this is sort of, you can see this nicely in this diagram. So of course we can do all of this also algebraically if we have a given function, and here we have an example. So say we have two marginal cost curves. The one for plant 1 is just Q1. The one for plant 2 is 1 plus 0.5 Q2. So that means, as we've seen in the diagram before, that this one here intercepts the y-axis at 1, so a bit higher than this one, which intercepts at 0, and but this one is flatter. Yeah, if we have these two curves, and then we have seen that the first thing we have to check is that that it doesn't make sense to produce everything in just one plant, and this would be the case. This would mean that Qt is just equal to Q1 in this case. This would make sense if the marginal cost of producing everything, Qt, in plant 1, so this is the marginal cost of plant 1, and producing everything in plant 1, if this marginal cost is smaller than the marginal cost in plant 2 at 0, or with a very small amount, then this is a good idea. So if this is not the case, if the marginal cost in plant 1 of producing the total amount Qt is actually larger than what the marginal cost would be if we would just produce very little in plant 2, then we must have that the marginal costs are equalized, and that would mean that Q1 is equal to 1 plus 0.5 times Q2. So that gives us a relationship between the size of output we want to have in plant 1 and the size of output we want to have in plant 2. Okay, so if now we want to answer the question we posed before, we want to produce a total of Qt. What we have to bring in as well is the fact that Qt is the sum of Q1 and Q2. So, and if we use this to replace Q2 here in this equation, then we get this equation, and now we basically have only Q1 left in this equation, and we can solve for Q1. So that's what we're doing here. We solve for Q1, which is this expression 1 plus 0.5 times Qt divided by 1.5. And then, of course, we can immediately also calculate Q2 as Qt minus Q1. So for a given Qt, total production of Qt, it immediately gives us how much we should produce in every plant. And the main criterion here is that the marginal costs have to be equalized. Okay, so you might be asking how this can be used in the context of profit maximization, which is what we've been doing before, by the firm, and it works very similar as we did it before. So what we have to do again is to think about the profit function. The profit function now depends not only on just Q. There are now two types of outputs, the output of plant 1 and plant 2. So we have these two arguments, and then we can write it down as it's done here. So it's price times the total quantity that is being produced in both plants minus the cost from plant 1 and the cost from plant 2. And to find the optimum, we can take the derivative again, but now we have to take the derivative with respect to both of these arguments and set it 0 here for derivative with respect to Q1 and here Q2. Yeah. So the equations you get then as a consequence, or this leads to these conditions which look very similar like the one we had before. So previously we had just P is equal to the marginal cost, but now we have two types of marginal costs. So we have the price has to be equal to the marginal cost in plant 1, and the price also has to be equal to the marginal cost in plant 2, which of course means then that the two marginal costs are equal as well, which is exactly what we have seen before in the previous slides and diagrams. And here now, once we have a competitive firm like this, which just equalizes everything with the price, then these two equations give us, first here we can solve them for Q1, this one we can solve for Q2, and then the sum is the total output that the firm is going to produce. And you can also write this down or draw it very easily. Again, now we use again the diagram where we start both lines on the left hand side, here plant 1, plant 2, and let's say the price is here at the level of PA. So since this level of PA is higher than the intercept here, right, we produce output in both plants. If the price was lower, if it was below the intercept, then we would only produce output in plant 1. And then when we produce output in both plants as here, then the marginal costs here have to be equal. Yeah? But of course the only way to get these equal is if we produce much less in plant 2, so just Q2 here, than in plant 1, which is Q1 here. Yeah? And then the total of these, will be our total optimal output.